Hello, this is Andrew, and in this video I'm going to be discussing how to create a part studio based off of a main sketch for a large robot project. So we have in front of me a sub-assembly part studio for a project I have been working on recently. We have a large variety of parts in this part studio and a large number of features. And as you can see, we have both parts and sketches in this studio, so it's important to recognize both. Before you start, you want to make sure for a sufficiently large project that you have a proper layout sketch. So this is usually a main sketch that details in multiple views how your robot should look geometrically. So your primary view is going to be your side view, which this is. This details the side view of most of the components on the robot. There is a somewhat empty front view over to the right. At one point it was filled with sketches, but those sketches have since been deleted. And over on the left is a top-down view. It's not fully conclusive. As you can see, there's information in the right view, the side view, that is not on the top view, and certainly isn't in the front view. However, we only put the information that we need in each sketch. So for a lot of this, we don't necessarily need all of the information in every sketch, so we only carry over specific components. For example, this piece right here represents a horizontal piece of 2x1 aluminum tubing, and it is important that that piece is placed in the top view so that we can properly space out where these tubes will go on the frame, as these two tubes end up being the primary mounts for the majority of the structure. So once you have your sketch mostly done, you'll want to take it over to a part studio. Once you're in that part studio, you will be using that sketch to drive a lot of your designs. A common way of solving this is by copy and pasting the sketch from one part studio into another. This is not recommended and is considered bad form, primarily because the copy-pasted method does not have a link between the two parts. So if I were to copy a sketch over from the main sketch folder and then paste it into here and then go back and change the original sketch, I am not going to have those changes reflected in the new part studio, and that's bad because then we're going back and forth changing sketches and eliminating a lot of the advantage. So to show you how to do this correctly, I'm going to roll back this part studio all the way back to the main planes. So this is how it starts. The very first thing I did in the part studio was I used a derived function to import the sketch. So the way you do that is there's a derived tool right here. You click on that, and you can search in the current document, find the sketch, and if you click on the little arrow, it'll bring you the drop down of all the different sketches, or you can just click on the main one and then import. Click the check mark and it will be imported. I've already done that, so there's no point in redoing it. If you click the check mark, it should align everything such that it's on the correct face and that the correct origins line up as well. So as you can see, the original sketch was on the right plane, the sketch is on the right plane. Where the origin in the original sketch was is on the origin of this file. From there, the second thing I do is actually create a new plane. So why am I creating a new plane? The first part I'm going to make, if I were to go flat to this, is this tube, this 2x1 aluminum tube, which is offset from the center of the robot. So if I were to extrude the tube right here, it would actually be extruding from the center of the robot, from that right plane. And I want to try and model things in the part studio where they will be in the assembly. So in order to do that, I create a new plane to reference. So I create a new plane, this plane is offset from the right plane by 4 inches. You can see plane 1, 4 inches out from the right plane. So if I go over to this top view of my sketch, I would be willing to bet this distance here between the center line and this face is 4 inches, and it is. So it shows I did my job right. So I will be extruding this tube as a solid piece from the side instead of extruding it from the profile dimension, and that's because I will be using the tube converter feature script to create the tube. So now that I have it, am I going to extrude straight from the sketch? No. Try not to use these sketches directly, because this sketch is on this sketch plane, and you should be using these as a reference. Instead, I create a sketch on this new plane, this plane 1. You can see it there. And in the sketch, I actually do a couple things. So I'll open it up for you to show. In this sketch, I have selected this tube and this tube. You see no dimensions on these parts, and that is because these have been copied directly over from the original sketch by selecting a sketch contour and clicking the U key, which stands for use. Converts it over from the old sketch into the new, just as I've done with this line. We do this so that if we ever change the original sketch through the original main sketch in the other folder, then this will update and change appropriately. This also allows us to extrude this from the spot we want to put it on, which will be helpful. So we use an extrude individual, and that's because we are extruding multiple components. We've created this piece, this tube, and this tube. And you can see that they are not on the right plane, but they are 4 inches offset where they should be on the robot. The reason we only did one of these vertical pieces, even though there's 2 of them in the model, is because we only need to model one component, and we will add others in the assembly. From here, I use a single tube converter, and I convert these 2 tubes into their correct orientations. Do note that this tube right here is actually facing the wrong direction, and I did try for some time to get it to face the right direction. My guess is that's just how the tube converter feature script works. It thinks that it wants to go this way. I didn't end up changing it simply because at the end of the day, this didn't change how the part was modeled, and I eventually went on to include it in the assembly in the correct orientation. Just a thing to note. So here we have the offset tubes. I add a sketch, and this sketch now is actually on the face of this front tube. You can see it right there. I will do another extrude individual, and I model these as 3 individual tubes. I use another tube converter, and there it goes. As you can see, we're modeling these tubes exactly where they will end up in the robot. And we're trying our best to only model one of everything. We continue on with another sketch. This is now a gearbox plate, modeled on the tubes in the face where it will be. There will eventually end up being multiple gearbox plates, one on the right side and one on the left side. Because they are the same, we only model one. Now, something of note here. This sketch is on the inside face, but the part is on the outside face. Why is that? That's because I made a mistake, and I modeled the sketch on the inside face. And for some reason, even though I should be able to change the sketch plane and have the sketch update accordingly, the sketch would break every time I did that. and I didn't want to redo my work since I knew of another way to solve the problem. So if we open up this extrude, we use that sketch, but we had a starting offset of 1 inch. So I knew this tube was 1 inch wide. I offset it by 1 inch, and that solved that pretty easily. Although now that I look at it, this did not select one of the holes. So let me fix that right here. The wonders of CAD. So even though I modeled this on the wrong face, I was able to offset it so that the part is in the correct location. The part was originally going to be on the inside, and then I later on changed my mind in the design process. When I went back to change it, it was giving me errors, so I found a way. The next thing I did was add this rectangle to the bottom, a very interesting piece, and it's a sort of cheater method I've been doing. The purpose for the rectangle is to give me a way to mount the assembly in the correct locations. So this rectangle is on the top plane, and the way it works is if I go over to the sketch, it's actually mated as a center point rectangle from the origin out to be coincident with the corner of this tube. And the reason I chose that tube specifically is that was going to be the bottommost corner of the assembly. So when I went into the assembly, as we will come to learn, there's no assembly reference geometry in Onshape right now. There's no planes. There is an origin, and that is it. So it's not very helpful. There's no mirroring either. A little annoying. But instead what I do is with this flat rectangular sketch, I effectively make a floor that is centered on the origin that is the exact size of my main base. So when I go to put parts in, I will reference these parts as a mate to this corner of this sketch. And I'll show that when we get to the assembly. So it's a little cheat method I've found. An easy way to get some geometry, some reference geometry into the assembly without having to actually make a dummy part. A lot of people make dummy parts, and I'm not a fan of that. Going on, after that, I made a gusset with a sketch. You can use the gusset generator feature script. I just want to do something specific that's made on that tube. And you're noticing how we're trying our best to model the parts as they will be in the assembly. Put it in the right spot. After that, let's see what loads. I get another gusset. And then I model a thunderhex shaft. So this is the main shaft for my shooter wheel, as referenced by that circle. The way I made this thunderhex shaft was pretty interesting. The first thing was I knew the shaft was going to be symmetrical. If you don't know the shaft is going to be symmetrical, this is a harder thing to do, but I knew I wanted it to be the same on both sides, and symmetrical about the center plane, the right plane of the robot. So when I went to my shaft generator, my origin was the vertex point, center point of my shooter wheel sketch. So it was that point right there. Oop. Sorry about that. So it was the center point of that right there. And then the end point was a 3/4 inch offset from this plate, from this face. Why 3/4 of an inch? It was not the original number. Originally, I had no idea how far I wanted to stick out. Mostly because that's going to be dependent on what lies on the shaft, which is a spacer and a pulley. And while I could have done the mental math to figure out the size, I instead just made it something arbitrary and then went back to change it later. The nice thing about CAD is it's very easy to make something come back with new information later and update it. And so that was a very helpful aspect. So I made it to some arbitrary number. When I started building my my assembly, I put the bearing into the hole, I put the spacer on the bearing, I put the pulley next to the spacer with no shaft in there, and then I measured what was the distance from the outside of the pulley to this face of the plate. The number said 3/4 of an inch, so I went back to this feature, changed that offset to 3/4 of an inch, and the rest is history. So after this, I made a mirror feature, and I mirrored the shaft about itself. So before the mirror, the shaft was only this long, and then I effectively doubled the length to go through the other side. This is a method I've been using for symmetrical shafts for a short while now. There's a couple tricky methods that you can do to get shafts the way you want them and keep them properly modeled. And I'll hopefully try and get through those at a later point. When I say properly modeled, I mean modeled in a way where you can change the file or change the dimensions or change your model, and the shaft will update properly. There's the easy way of making the shaft, which is select a point and blindly extrude and then just keep updating that. And that was the old way. But with the top-down design in Onshape, the proper modeling technique is to try and do things in a way that allows you to change one dimension and have the rest of the model update and do the work for you. So in the pursuit of efficiency, so to speak, and really the elimination of errors, this is a method that I've found is good enough most of the time. It doesn't solve everything, but it solves some things. From there, I added on this component right here. This is a little bearing retainer. And this component actually uses several different features. So there's a couple, one right there, and then there's this feature to add a little cutout on the inside. If I were only using one kind of bearing retainer, I would only have modeled it once. But because these two are different shapes, I modeled each one individually. I will be using two of each, one on each left and right side of the robot, but I only need to model one. That being said, I say, as I just make a statement and prove myself wrong, I do actually have to model two of this one. And the reason being is this one is not symmetric left-right. If I were to flip this to the other side, without actually mirroring the component, I would create a non-symmetrical figure. So I cannot take this part as modeled, put it on this side, put it on this side of the plate, because it would be on that side of plate on the other side, on the left-hand side. I cannot take this and flip it over, because the part itself has this little cutout. And if I were to flip it over and put it on this side, the cutout would be on the outside, not the inside. That sort of defeats the purpose. So I recognized that, and I used the mirror tool, and it created a mirrored copy of the part. Something to note, and I haven't brought this up yet, and I just realized I probably should. As I create these parts, I'm going and getting new bodies over here. I'll say new component. So I'll always right-click, and I'll go through these top three. I'll go through Edit Appearance, Edit Material, and Rename. I skip Properties, because that gets solved for the most part. So every time you create a part in Onshape, it gives it a random color, and it's very fun for some, but I prefer to make things look the way they are supposed to look. Most parts are metal or black. That's pretty straightforward. So you have like the aluminum, silver, gray, or black. So when I go to Edit Appearance, if it is an anodized black part, or if it is a 3D printed part, I model all 3D printed parts as black. I use this color right here, the one with the check mark, bottom right of the left-hand grouping. If it is metal, I use this one right here. It's between the dark and the light blue. So you can see that matches the same colors. I'll put it back. So if it's a shaft that we purchased that's normally anodized black, or if it's a 3D printed part, or if it's a pulley, or if it's a component that's normally a specific color, that's the black I use. Or it's actually a gray, but if you use the black, like you can't really see the detail. So I prefer to see the detail. And it looks nicer, I think. Do that, and then I use the lighter silvery gray right here in the center for aluminum. Any other part, I try my best to match its color. It is important to me as an individual that the CAD is visually representative of what the final outcome is supposed to be, both from an aesthetic perspective, and I also think it's important for communication purposes. If everyone can look at something and see what it's supposed to be, it increases communication and it makes things less ambiguous. So there's a little bit on that. So that's the appearance. If you go to edit material, I so far have been putting ABS for all the 3D printed parts. It's not accurate, but it's light enough that I kind of just don't care to find a better solution at the moment. I am sure there's a better solution somewhere, and if someone finds one and tells me, I will happily take it. But I just put ABS, even though we're printing PLA and then eventually nylon or PETG for most of these other parts. Aluminum parts, I will search 6061. There's aluminum 6061. Rarely I'll search 7075. If I know it's a 7075 part, or if it's a shaft, I'll make it 7075. Some feature scripts will select for you. So I know tube converter automatically sets a part to 6061. Shaft generator automatically sets the shaft to 7075. And then finally, name. You get some like untitled part or whatever. It says part 17. I'll always click rename and give it the proper naming convention. The next file in the order. So 8, 9, 10, 11, 12. Pretty straightforward. Just something I wanted to touch on. So as we go through, the next step was I made a belt. And this one was actually a little bit annoying because it was important to me that the belt was in roughly the right place. So in order to do this, I actually started over in the assembly, which I'll go over to now. In the assembly, I had the pulleys placed before I even had the shafts. Because ultimately I had it's barely seen there, you got a bearing, right? And then I had the cover over it. You have a spacer. Pulley connects to the spacer. So I don't actually need to have the shaft in there. So what I would do is I would measure how far is this inside face of the pulley from this face of the plate. We got 0.259 inches. And what I ended up doing was I went over to my part studio, and when I used the contextless belt feature script to create this, I selected the two circles, and then I had to create a funky offset. And that funky offset was the offset I got from this value, which the negative 0.26 is the original measured value plus the value of the space plus the now in this case minus, because it wants it to be negative, the width of the belt. To show you what happens if you have 0, I'll copy that. It actually puts it on the inside here. And that's not where I want it to be. I don't want the belt to be on the inside. I want it to be on the opposite side. However, I could not find a way to flip the orientation. If I could, I would flip the orientation to be on the outside and then space it apart by the number that I measured, and then I would have been fine. But that's not the case. So I sort of had to do some trickery and do something like that, which was good enough. It's not hard. It was just annoying to figure out. But now that I've figured it out, hopefully you won't have to. Anyways, I've gotten the belt. I put the correct sizes, the 16 to 36. A nice thing about the belt generator, contactless belt generator, is it tries to approximate how many belt teeth that you're going for. The one thing is it doesn't really account for for center add or center subtract. So for a lot of belts, I subtract 20, 30 thou from the center, and that just makes it so it runs a little looser, which increases the efficiency a little bit. You don't want to be too tight. It accounts for manufacturing tolerances. I'd rather be a little too loose than a little too tight. So I do that. But now what's supposed to be a 65 tooth belt, it thinks is a 64 tooth belt. And that's just how the feature script is written. And that's fine. I know it's a 65 tooth belt. So what I do is in the name, I write a 65 tooth 3 millimeter belt. And that helps indicate what it is, how many teeth it is, and when we go to our bill of materials, it'll help us purchase the right component. So I do the same thing with another belt. It says it's 69 teeth. It's actually 70, and it's this one right here. I did have to custom input the size and thickness of the belts, but that's information I had on hand, and if you don't have it on hand, then you should ask me, because I have a document detailing it. So I made those belts. I made this shaft using the same, using a similar method to the original one. However, I didn't have to mirror it over, because I actually had my start and end point already figured out thanks to this component. So I referenced this face right here, so I referenced this inside face right here, and then this outside was measured based off of the pulley. There was some weirdness there. I wanted to offset it from this over here by 3/4 of an inch, because remember we did 3/4 of an inch over here. I don't know what I did wrong, but I had to offset by 1.5 inches over here. For some reason it was unhappy with this. I'm trying to remember. Yeah, actually now I'm a little confused. I'm discovering things on this journey with you, so, you know, let it be and we'll figure it out. I did only do this yesterday. Let's see. Next, I modeled a sketch up here. This is for a little plate component. Oh, and here's one. Okay. So this plate is a polycarbonate plate. So when I made this part, I go to edit appearance, I want to use smoked polycarbonate. Smoked is the black, darker one. It's still transparent though. So I select the black color that I typically use. However, here, this little A over here, is for the transparency. So I changed transparency to 0.5 instead of 1. 1.0 is solid. 0.5 is, well, half, I suppose. But I found it's a good representation of polycarbonate. So that's how I color that correctly. Material is polycarbonate. We have that in the library, in the material library. And then I renamed it the correct name. Over here I put a thin metal piece on the outside. That's a design choice, and while it's one that you should know, it's not the purpose of this video. Let me just go through. I made a 3D printed piece with a bunch of small little features. For the 3D printed piece, same as the other one, it should be modeled as ABS for the material. You can see it's that same black. I made a new plane, and that's because this new part I was making is not in line with this, and there was nothing else I could reference. This new plane is, if I were to go to there, is actually this right here. So this is 11.25 inches off center. So just to confirm I did my job right, this new plane I believe is 11.25 inches off center. Perfect, there it is, right off the right plane. And this is because this is a piece that is going on the drive tube itself on the side. So I made that. I have a sketch here. And again, this sketch was already, let me actually roll back. This already exists in that main sketch. When I started this subassembly, this did not exist. When I started making most of these parts, this little rectangle, this diagonal rectangle did not exist. Instead, I eventually added it to the main sketch to the main sketch part studio. And in putting it there, because I derived the main sketch all the way at the very top, it updated. It included it into this one. So all I needed to do was use those lines to create a sketch. I extruded that sketch into a block, and then I tube converted, and there it is. Very easy, very straightforward. Let's see, what piece is this? Oh, I added a round tube between these because I was able to model this so that one hole would overlap on each. So we see these don't overlap, but the center one does, and that's actually what this line and this line are for. I make a gusset there. I have a gearbox plate that I've started, and then a second gearbox plate that I will finish. But yeah, so that's sort of how this has come to be. It's been very helpful modeling everything in the place it's supposed to be. A, because it lets me reference it with the correct features, and B, most importantly, it gives me a better visualization of how these parts are supposed to fit and how they work in a 3D space. And all of this is built on the foundation of having that derived main sketch that I used in almost every single component that you see here. When I eventually go over to the assembly, I'll show you how that works. This is what the assembly looks like. It's missing some parts. I haven't put everything in yet. Again, I did just start this yesterday. If I roll it back for you, well, let me roll it back. Is that a feature? Can I roll things back? I guess not. If you go to the very first thing, we have superstructure file, the name, we have the origin, which is the only reference geometry we have, and then a sketch, and it's actually that rectangle. The very first thing I did was put that rectangle in. Does it let me edit? Does it let me? No. Oh, it'll bring me back to there if I double click it. Okay, go to assembly. Learning new things. So anyways, I inserted, I'm going to go over to insert, go to part studio, and this right here, this little rectangle and circle means sketch. So I go over to my conveyor superstructure folder, I actually deselect parts, and here's the sketch. And these are the open sketches. I eventually just found the rectangle, like it's this one right here, sketch 4. Now that I'm saying this out loud, I think it would be a good idea to label it. So note to self, and now to you, wondrous watcher, name your ground rectangle something memorable so you can figure out what it is. So anyways, yep, first thing I did was put that in, and then I fixed it. Fixed simply means lock it in place. So because I modeled it on the origin, when I inserted it with the check mark, it was locked to the origin. I'll show you a quick example of what I mean with a check mark. I'm going to try putting it in again. When I select it, it puts it where I had it in the model. Now I can also click and, I can drag my mouse around and put it almost anywhere. But if I use the check mark, the green check mark, to place it, it'll place it where I had it in the part studio, which is at the origin, which is exactly where I want it. So I do that. I click the X in this one, but that's because I don't want to put one in. I did that, and then there should be something around here in the right-click menu that says Fix. Fix means I can't drag it anywhere. If I don't have it fixed, I can drag it wherever I'd like, and that's not very useful to me. I want it to stay at the origin, so I modeled it at the origin. I inserted it with the check mark so it went to the origin, and now I'm going to fix it where it happens to be on the origin. From there, I inserted this tube, and I inserted it with a mate to the sketch. So I used a mate connector with this corner right here. So that may place that pretty rigidly where I wanted it. And again, this rectangle is actually driven in size by the correct placement of this tube. That's why I model it the way I did. It is, if I change the Part Studio, the rectangle will update, and if I change the Part Studio and the rectangle updates, then the assembly updates because it uses the rectangle. Everything fits because it's modeled correctly. I also mentioned earlier that the tube that I made was in the wrong orientation. As you can see, I placed it in the right orientation. So yeah, pretty straightforward with that. I just knew that this tube was only going to be this tube. It wasn't going to change. And that I didn't really care what orientation the feature script wanted it to be in because I would just put it in the right one myself. So that was fine. I add 4 of those. I start putting all this together. And then from here, it's just mating things as normal. The only times things get a little fancy is when we finally get to wherever it may be. Is it in here? Oh, maybe not. You know, I bet it's down in here. At some point, I ran into the issue. Oh, here it is. Yep, this mate connector. So at some point, I ran into the issue of wanting to put this wheel at the very center, the inside face of this wheel on the center line. But there is no center line because there's no planes in assembly. So in a Part Studio, I can model this on the right plane so that it's contacting the center. So I could have one to the right of center and one to the left of center, which is what I wanted. I wanted to use 2 wheels. But there's no planes here. There's nothing I could have done. So instead what I did was I made a mate connector, which is right here. And I used this guy. I used a mate connector on the origin. I think it's the mate connector 2 right there. So when I place a mate connector on the origin, it gives you the option to put it along the X, Y, or Z axis, which are the only times these axes are ever referenced in assemblies, which is a pain because apparently they're there, but we can't use them. So I put it along the center line to represent a right plane. And then I added this in, and I made it everything relative to that. So that was extremely helpful. I do have 2 of them here. It's because I made this one first, and then I made the bottom one. I could have, I think I could have just gotten away with the bottom one, and then you made a planar mate between this and this wheel, and that would have worked. That's what I ended up doing with this pulley. There's a mate connector here, but there's not one here, because the mate for this pulley started as a planar mate with the inside face, so this, but on the inside. So a planar mate there in the center, with this little mate, with that little mate connector I made right here. So that made it planar with that, effectively planar with the quote-unquote right plane. And from there, I used a cylindrical mate to get it onto the shaft. So the cylindrical mate is a way of putting it concentrically on the shaft without defining its axial position. So the axial position where it was along the shaft was defined by the planar mate. So that's the way I've been getting around things. It's a little bit of a hacky way, but it's been working. If you follow this methodology, I think you will find that making robots will be considerably easier than sort of hacking and slashing your way through and fighting with the software. It does take a little bit of initial setup, but the time savings later on pay dividends. And I think it is very worthwhile to trust the process, execute it correctly, and then we'll reap your rewards. So I hope. And with that, I think that's enough for this video. I've been talking for too long already. So if you have any questions, always ask, and hopefully you find this useful. Thank you.